I'm Alex Williams of the New Stack here at the Intel Developer Forum. We're here to ask people, who is the Intel developer? It's a question that I have, as Intel is not ordinarily associated with developer communities. But the world's changing quite a bit. There's new data centers all over the world, and they have a whole host of capabilities. We're really entering a whole new world of software-defined infrastructure, which really means that developers can access the chips like they never could before, unleashing features that were just not there in prior versions. So we want to talk to them, hear what they have to say, and see if there really is an Intel developer.
We're in an innovative world right now, right? So people are finding all different kinds of ways of just how to get the basic thing done, which is how do us as people, get access to our apps and data, or how do we do crazy stuff like what we're showing earlier today on the life sciences, how to do personalized medicine. So for us, what we see is this wide range of different types of orchestration solutions are what's fueling and delivering the innovation. So fundamentally from the silicon, stepping up and actually you can take something like a Mesos that's very about that application at monster scale. You can take something like OpenStack that's more about multi-tenant environment that you don't really know exactly what people are going to do and what their virtual machines are going to do. But that also is a very strong orchestration layer that we connect to. And then you have the VMwares and the Microsofts that are also building these enterprise scale private cloud and public cloud solutions. So for us, it's basically how to make the brains that are inside the silicon pass all the way through to the end users. And so each layer of the stacks, and there's many stacks as you said, and that's a good thing. It's a good thing for the world, because then there's options for the app guys to basically try new methodologies or new optimizations, because everybody basically wants to play a Tetris game and optimize their solution, right? So I want to make sure if I'm doing like Waze, right? I want to make sure that I can do it at the lowest cost and hit the largest number of people. If I'm building OpenStack as a developer, I want to make sure that my OpenStack services get the best usage of the infrastructure and expose it out to the end user. So each person is looking at optimizations, and so what we see is each person's trying to play this Tetris game of placement and finding how to basically constantly optimize their various processes. And so if you take it all the way, again, from the end user to the silicon, we basically see optimization at every layer through orchestration.
My name is Matt Bunting. I'm with the University of Arizona. So I developed a hexapod robot named Dimitri in 2009, and that was part of a undergraduate class project. So recently, the guys at Intel decided to convert the original computer to run all of my code on Intel Edison. I was posting my project to a hexapod robot forum, of all things, very specific, because I wanted to show it off. There were other hexapod robots that were out there. So I posted a video on YouTube, and I also posted it to a forum that created this computer, the CompuLab Fit PC2. And I believe Stuart Christie was following this company, and Stuart Christie works at Intel. So then Stuart Christie messaged me on YouTube. So before Intel discovered me, I did have access to a 3D printer, and that's where I designed all the parts in SolidWorks, and I used a 3D printer to build them. And fortunately, at the same time, CompuLab had just released this Fit PC2, which has an Intel Atom processor. So that's what really sparked the interest in Intel's eyes, is that they're using a computer that's not used as a traditional computer for checking your email. It's used in an embedded system. So you have a full-blown computer that's doing a lot of computationally intense tasks. So one of the best parts is that this whole computer is able to be replaced by the small Edison chip. And in 2009, this was amazingly small for what it was, to be running a full-blown computer with a hard drive and everything inside of this. However, that can all be replaced by this. And that includes also the Wi-Fi and Bluetooth antenna, which is this little chip antenna right here. So it's very impressive that I can reduce the weight and reduce the power consumption as well at the same time by using this Edison chip.
My name is Katie Hausner. I work in the device development group at Intel in Hillsboro, Oregon, and I've been at Intel for about 15 months. I graduated in May of 2013 with a degree in general engineering, and what I get to do is new concept development. So a lot of brainstorming and then a lot of putting together off-the-shelf components in order to make new computing devices. So it's really cool. And over the past few months, I've been able to do a really cool project with a bunch of students from Oregon State University. And this started as part of the OSU Collaboratory program, along with Intel. And we came up with a project for the students to do, and that was to create a smart bicycle helmet that would increase the safety of the wearer by being able to contact emergency services if a rider has an accident and cannot respond to a prompt about whether they're okay. So we had a team of 5 students during the school year who built our first prototype, and then 4 of those students came to Intel over the summer and participated in the Edison beta trial with us. And we converted our first helmet prototype over to using Edison as the brains. So the smart helmet is a connected helmet. It uses Bluetooth to connect with your phone, and on board the helmet there are a number of sensors that can be used to determine whether or not somebody has been in a bicycle accident. So when these sensors detect that there's an anomaly, that perhaps you came to a very quick stop, like unusually fast, it causes your phone to prompt you to see whether you're all right or not. And if you're unable to respond, or if you respond, no, I'm not okay, then it's going to initiate a phone call to your emergency contact or to emergency medical services. And it will also text that contact with your GPS coordinate. As I rotate the helmet, you can see the gyroscope data in particular reporting changing values. This is definitely the proof of concept, but we are, in the conversations to figure out where this is going next, and we'd really like to go further with it.
So, who is the Intel developer?
Yeah, so there's a few types. With bridging the silicon to the developer, we're basically looking at 2 major types. The first type is the one that's giving out the applications to the end users. So we're starting to see more common that if somebody's building a mobile app, and say they're running on a public cloud, they actually now want to know what they're getting underneath, because there's certain applications, like let's take encryption as an example. If you can land on a box that has ASNI, some people will even get 10 to 50x better performance. So this application developer wants to know that they can get specific type of performance, because again, they want to do massive scale at the lowest cost possible with good performance. So they're starting to understand the more advanced ones. Hey, I have to find this. And what we announced today was some work with AVX 2.0, which helps with floating point and life sciences. So this type of application developer wants to basically be able to see that they can get that high-end performance for personalized medicine. So they're building also, again, applications at this high level. The second level is the guys building infrastructure services. So these are the guys that power the next level up. And these are the guys doing the software-defined networking solutions, the software-defined storage solutions. So the guys building those resource schedulers, the Mesos, the OpenStack. So them too, they want to make sure that what they're supplying to their end user is constantly optimized. That's their secret sauce, is how do I take this infrastructure and give it out to the app developers on top with super fast performance. So Intel basically focuses heavily on those 2 layers. The guys building the applications all of us love and enjoy as normal consumers, and then the guys building the infrastructure software that powers those. And that's really where we're seeing a lot of the innovation happening, where we're, even Google, like open sourcing Kubernetes, the Mesos guys, the OpenStack guys, we're seeing a viral pattern happening at the infrastructure layer, as well as what's being driven by the application guys for all of us.
Because the developers can reach deeper into the stack more than ever before.
Exactly.
And pull out capabilities and feature sets that allow them to, again, as you say, optimize their applications at the lowest cost possible.
Exactly. And everybody's always trying to optimize or think of a new way to do something better than somebody else, right? Because it can be a 2-second issue that changes somebody's mind from using one app versus another, right? So you want to be able to dig down and see what's happening and ask for the right stuff. I mean, our vision is that telemetry and orchestration, we have this concept that we watch, we decide, and then we act. and then we learn as we do this. But we have this concept that this will eventually become, autonomic, right? We're actually kind of far from that, but where the application developer can basically state what they want, and the system will actually take care of all that for them. Today, we provide the visibility, so they make them choices themselves. But as we're seeing with things like Mesos and OpenStack, we're building in plumbing that basically allow that orchestration software solutions to make its own decisions. And so it's like playing a Tetris game, finding the right resources so the app guy gets what he needs, so the end users get what they really need.
Great, Toss. Well, thank you so much for talking with us, and glad to be here at IDM.
Yeah, thanks for coming.